In this video, we will look at the pegs included in the Lego Mindstorms core and expansion kits. In the description area below, you will find a link to a list of all the parts we will discuss, as well as a few additional parts that we will use to see how the pegs work. You will find it helpful to have the pieces available as you listen to the video. Please pause the video now, get out the parts, and then come back for the discussion. Now that you have the parts ready, let's start our discussion of Mindstorms connectors. Connector pegs are commonly called pegs or pins. They are used to connect pieces that are next to each other. Most of the pegs have a friction and a non-friction version. Let's get out the pieces that are in container number 1. We have a connector peg with friction, a connector peg without friction, and 2 Technics 7M beams. And I have put the 2 little pegs in my little bowl that I have here so that they won't run away from me. These short pegs are used in round holes and connect 2 parts that are 1 m thick. The 2 pegs that we have in container 1 are colored differently. The friction peg is black and the non-friction peg is light gray. If you cannot distinguish these colors, you can tell the difference by feeling for the friction ridges on the connector peg with friction. The non-friction peg will be smooth, but you can feel some small ridges that run parallel to the length of the friction peg. And you can feel them sometimes with your thumbnail. They're short, they run perpendicular to each end, and then they also have some very short ones that are perpendicular to the center bump. So if you feel that center bump and run your thumbnail along there, you can feel the little ridges. The other thing that's different about the one with friction is in the center, running parallel to the length, there's a slot on either side. Both pegs have slots on the end, little slots on the ends, but the one with friction is the only one that has a slot in the center. Now let's see the difference between a friction and non-friction peg by using each one to connect 2 beams. And I'll put the non-friction peg in my bowl, and I'm going to insert the friction peg into the last hole of one of my 7M beams, and then I'll connect the other 7M beam so that I get a long length here. And I have them in kind of a straight line. Now I'm going to pick them up and hold one of the beams by the end. And you'll notice that the other beam is not moving, it's staying straight out. Now if you hold on to it, you can turn it around on that pin. It just has friction, but it's not perfectly stable, but it has enough friction to stay where you last put it. Now let's take that friction peg out and put the non-friction peg in. I'm again putting it into the end of one of the beams and then putting the other beam on top of it. And when I have it flat on my table, I have the 2 beams straight in a line, and now I'll pick it up and hold on to one. And you can immediately feel that the other beam is swinging freely. So that's what the non-friction means, that it'll move freely. And it doesn't matter, it's the same on both ends of that peg, so if you hold on to one of the beams, the other one moves freely, and if you hold on to the other beam, the other end moves freely. So that's the difference between friction and non-friction. So we'll put these pieces back in container 1 and get out the pieces that are in container 2. In container 2, we have one connector peg with friction that is 3M long, and we have a connector peg 3M that's without friction. And then to help us understand how these pegs work, we have 3 Technic 9M beams. So these pegs are also used in round holes. They are 1M longer than the first set of pegs, so they can connect 3 beams or 3 parts with round holes. The friction peg is blue and the non-friction peg is tan, but if you cannot distinguish these colors, you can tell the friction from the non-friction by feeling for the friction ridges like we did for the smaller pegs. And then also in the friction peg, there are 2 slots that run parallel to the long edge, to the long side of the pin, and on the non-friction there's just a tiny slot running parallel to the length of the peg, and it is only on the longer 2M side. Note that both of these pegs have a bump in the middle. Well, it's not in the middle, it's more towards one end. There's a shorter side and a longer side. On the shorter side, you can put something with the depth of 1M, and on the longer side, you can put something with the depth of 2M, or you could put like 2 beams on there. And we'll see that in a moment here. When you build with these pegs, the instructions will always indicate which end of the 3M peg should be inserted first, whether it's the shorter side or the longer side. In our experiment, we will first insert the short end of the peg into the end of the 9M beam that we have here. So I'm going to take one of my 9M beams and I'm going to use the friction peg to begin with, and I'm going to insert the short end into the end of that beam. And then I'm going to add another one of my beams right on top of that, again using the long hole. And you can feel that there's still room to add even a 3rd beam on there before we run out of connector peg. So you can see you can have 3 things coming off of that one peg. Again, since this is friction, the pieces kind of stay where you leave them, but you can move them around. Now let's try that same experiment with the non-friction peg. I'll take this friction construction apart. And then I'll insert the short end of my non-friction 3M peg into the end hole of one of the 9M beams. And then I'll put the end hole of another one on top of that, and the end hole of the 3rd one on top of that. And as you pick up any of these, you can see that everything moves freely. There is no friction at all in there, but they are connected firmly at that one point. So that is the 3M pegs with friction and without friction. And we'll put these into container 2 and pull out our parts from container 3. In container 3, we have one connecting bush with friction and cross, and one connector peg with a cross axle. Even though those names are slightly different, they both mean the same thing. That on one end there is a round peg, and on the other end there is a cross axle. Now one of these is has friction and one of them does not. And we tell them the same kind of way by looking for those little friction bumps on the one with friction. And you have to kind of put your fingernail right next to either the center bump that runs around the peg or right next to the end. There are no additional slots to help you identify these, the difference between these 2 pegs. If you can see color, the one with friction is blue and the one without friction is tan. We also had a couple of parts in our container to help us demonstrate how these pegs work. I'm going to put the non-friction peg in my small dish for a minute, and I'm going to take the friction peg and I'm going to put it into the cross end. There's a cross hole on the angular beam, and you can use either end, the 4 by end or the 6 by end. They both have a cross, and this is just to demonstrate how you can have a cross on one side, and then if we take our 7M beam, we can join that because it has a round hole on an end. And because this is a friction connector, the connection stays kind of where we put it until we physically move it around. Now let's take this apart, take out that friction peg, and put in the non-friction peg. Now because that cross fits tightly into the cross hole, that side is going to stay steady. But it still kind of spins because the whole unit spins on the round side. So you can, when you pick that up, you can feel that there is no friction at all in that joint. So those are the two friction cross-axle pegs. In container 4, we have a little connecting bush that is 1.5 M, whereas the other pegs that we have been looking at were at least 2 M long. This one is only 1.5 M long. That means that on one side it is only 1/2 of an M long. We also, to demonstrate how this piece works, we have a Technic 7M beam and a Technic lever that is 3M. This little peg, the short side, fits into a lever. Now a lever is a special beam that is only half as thick as a regular beam, and in fact, if you have, since you have both beams out here, you can just feel the width of them both, and you can feel how the lever, which is a half beam or a thin beam, is only half as deep as the long 5M beam that we have, or 7M beam that we have. So the little short side of our 1.5 connecting bush is round, and the lever has a round hole in the middle, so we can put that round hole right there inside, and nothing will hang off the edge. And then on the longer 1M side, we can put a beam just like a regular beam, and it fits just right. So that is the 1.5 M connecting bush. Let's put those parts away and get out the parts that are in container number 5. In container number 5, we have a friction snap 2M with cross hole, and then to show how it works, we have 2 Technic 5M beams and a 6M cross axle. Now this is a very interesting pin. Feel how one end is quite large. It's actually shaped just like a bushing. A bushing is a piece that goes over a cross axle, and you can feel in the end that there's a cross for an axle to fit in there. And we'll see how that will work in just a minute. Now the other nice thing about this pin is that thicker bushing on the end provides a nice handle to quickly and easily put this piece in and take it out. So it's often used for easy connections between modules or for connecting specialty attachments to a robot base. So let's see how to use this pin. I'm going to take my 2 5M beams and put one on top of the other, And then I'll just put the long 2M side of this peg through 2 of the holes, and it doesn't matter which ones. Just push it all the way down and you'll see that it can put those 2 beams together. But then feel how easy it is to remove that, because you can hold on to that bushing end and it can easily pull out. And then finally, let's see how we could use this peg to connect an axle. I have a 6M axle here, and I'm going to push it into the end that has the cross hole on it until I feel it bump up and stop. And that is a 1M thick bushing there, so that if I put a 6M axle in there, I have 5M axle left over. So you always lose 1M of length of an axle when you put it into this peg. Now let's put these pieces back in container 5 and get out the pieces that are in container 6. In container 6 we have 2 pegs to look at. They each have a ball on the end. You can feel that round shape. And then on the opposite end, one of them has a cross axle and one has a friction snap. And they are used with a track rod or a steering gear to form a suspension system. So let's see how they connect. I have a track rod here that is 6M in length, and I've just picked up one of the pins, and I'm going to take the round end, and on the track rod there is a circular loop with a hole in the middle, and just push that ball end in until you hear a snap. And then the ball end is kind of captured inside of that loop on the end of the track rod. It can kind of move around freely in many degrees, but it stays inside of that track rod. And then the other ball, this time I have the ball with cross axle, I'm going to put it in the other end. Again, just push that ball end into that loop till you hear a snap or feel that it's caught in there. And then depending on, you can connect this to your construction depending on if there is a cross or a peg hole that you want to put it in. That's what will determine whether you use a ball with a cross axle or a ball with a friction snap. So for all of these pegs that we have seen today, we will see more of them in use when we experiment with construction ideas in our other parts videos. So just remember, when you're using these connectors, you may hear them referred to as pins, pegs, connecting bush. There's many terms, but they all refer to the same thing, just little parts that hold together 2 or more other parts.